SIP TLS and SRTP. Next module. Okay, so just an overview of SIP TLS and the configuration and how to troubleshoot. Same thing for SRTP. So TLS as its own RFC, and then you can, it allows you to encrypt SIP messages, and this will always run over TCP. You require certificates to be able to run SIP TLS, and you need to have ProSBC version 3.1 to support SIP TLS. Oh, sorry, which is the main version we give out anyway today. So one thing you can do is have a SIP RTP to SIP TLS and SRTP conversion. So then a network that is maybe a private network, which doesn't require encryption. If you want to go on a public network, then you will be able to use SIP TLS to encrypt the SIP traffic and SRTP to encrypt the RTP information. So to do the SIP TLS configuration, what you need to do is create a local key or certificate. You need to add this certificate to the SBC. If you have a 1+1 system, the certificates are replicated on the standby system. And one thing you need to remember here is that the keys are not saved in the database. If you get a database backup out of the system, the certificates will not follow. I mean, the keys will not follow in the database. Okay. The certificates will follow, but not the keys. Okay. Then you need to create a TLS profile that will use those certificates that you have put in the system. And then you need to add a SIP transport server of type TLS. Right, so I showed you already how to create a local interface on the system. And so you can add a TLS transport server to this list of local IP interface. Okay, to create those local keys and certificate, you need to, well, first create a new private key or use one that you already have that maybe you will be using on multiple systems. And then you need to create a self-signed certificate derived from this private key. And you need to create a certificate signing request also from this same private key. Okay. These keys will be or need to be stored at a specific location in the system. All right, so this is the path on the system where the certificates and the keys needs to be put. So to create a new private key, well, maybe you have already your own, or you can generate one from the system. Okay, so here I give you just an example of a command, okay, to generate a new private key. These settings can be changed or optimized to get more recent encryption schemes. Okay, so this is here just an example. Then once you have your private key, which is will be named like this, right? A name and dot key. You can create a self-signed certificate. And this is one example. And when you're using an OpenSSL on CentOS 7 to get your self-signed certificate. Okay. And you can create a certificate signing request, and this is the command to do this. Okay. So again, here, if you have your private key already, maybe you already have a certificate that is signed in the network, so you may not need to do this. But if you don't have it, then you can create them like this. And in the end, you will be left with 3 files. One is your private key, which should never be sent to anyone. And then you have your certificates, okay, which I will show you how to use them. In the SIP TLS configuration, you can add your local certificate. So you see down here, you have certificates. I should change this here. You have certificates like this. And you do create new certificate. And then you copy the content of your CRT file in this text box. Okay, so you just copy it, paste it here in your text box, and then this will be your local certificate. All right, so it's a certificate that is owned by you, so you have to put it here in this box. Then you need to create another certificate for the remote side. Okay, so the remote side will have done the same process, okay, and they will give you their certificate so that you can match it from end to end. So you need to copy the content of this remote certificate in the same text box, but in this case, you will have you will add a certificate type of a trusted destination. All right, so you have the local certificate, which is yours, and the trusted certificate, which is the other side. Yeah, so Sharad is saying, can we use Let's Encrypt certificates for TLS profile? Absolutely. Okay, absolutely. What I showed here is just one example of how these certificates can be created. Okay, so now you have created your certificates. So you will need to have certificates for each of the destination you will want to use SIP TLS. Okay, and then you need to create a TLS profile. This TLS profile will say, do I need to provide trusted certificates? Then normally you would say here, yes. I need to exchange the certificates and verify that they are valid. And here you will specify your local certificate and the remote certificate. All right, so you will need one TLS profile per destination that you want to reach in the system. Once you have created that TLS profile, then you can go in the transport server. So SIP and transport server. And you see here, you will choose the protocol type of TLS. And then the TLS profile we just created. Okay, here it just mentions TLS profile, but maybe it should be more useful to be saying a TLS profile for a specific network. Okay. So here you set it here, and you can say from which IP interface you will use this TLS profile. Okay. Yeah, so the default port for TLS is 5061. So that's what you need to use if you want to have TLS default. But you can change that, of course. Okay, so once you have done this, you can create a NAP, using this TLS profile and this SIP transport server. And if the remote side is also using TLS and has your certificate, then when you make a call, this will work. Okay? So you can see the status of this particular TLS configuration by looking at the SIP stack status or the NAP status or the certificate status. Right, so certificate status here will show you if the certificates are valid. Okay, so it can just verify if the date is correct and the issuer is correct here. In the NAP status, well, you will see if it's up. And if it's up, it means that there was some exchange of SIP messages, but not only SIP messages, but also all the TLS encryption message exchange that happens before that. So when you see the NAP status up, it means all the TLS connection has been made and is working. Okay. And then you have SIP stack status, which is mainly just the transport server, the local interface, to see if that is up. To troubleshoot the TLS, you can first look in the call trace. Okay? So in the call trace, the TLS messages will be decoded. So even if you're using TLS to make a call, it will be decoded in the call trace because this is done, the call trace is done at a level higher than the SIP stack. So the SIP stack has already decrypted the messages, and the information that is shown in the call trace is at one step higher. The only way to know that this is a TLS call is to look into the call trace and see if it's written TLS here. Okay. Usually it's written SIP UDP or SIP TCP, but if you're using a TLS, it's going to be shown here. If you cannot find the problem, or if the TLS here doesn't show, you can try to use a TB trace. TB trace will also have the SIP trace decrypted. And if you look at this trace in Wireshark, you will see it as UDP and not TLS. Okay, so that means the SIP stack will decode the TLS, and when it does this signaling trace, SIP signaling trace, it will put it back as a readable format by Wireshark. Because if you just give a TLS SIP exchange to Wireshark, it won't be able to decode it. All right, so both of them, call trace and TB trace, will have the decoded information inside, so you can really see if the SIP calls are working and if everything is okay. Now, if you can't get the TLS to go up and you don't know what is the problem, maybe you need to have a Wireshark trace, which is lower level. I mean a TB router trace, which is lower level, and you can use Wireshark to decode it. Okay, so TB router trace, I will show you how to do that after. Okay. If you capture the TB router trace and you have the ability to have the private keys, and like I say here, they're not always available, of course, because if the remote side doesn't want to give you the private key, you won't be able to decode it here. But if you do have those and you input those private keys inside Wireshark, okay, so you have to go here in TLS and add the keys. You can see all the SIP TLS messages. Okay. So here I say either a TB router trace, which is a low-level trace on the SBC, or it can be a trace taken on the remote side as well. This will give the same type of information. But TLS, of course, is a bit more difficult to troubleshoot. So, of course, you need to verify if there's IP connectivity end-to-end, just to eliminate that portion. You have to verify if the local IP interface that you are using is the right one, and also if you're using a TCP, the TCP port, make sure it's the right one. The remote port needs to be the right one as well in the NAP configuration. So these are all things we need to verify. Okay, and I have some examples of call trace, signaling trace, and TB router trace that I can show you for SIP TLS. So when you download a call trace, you have something like this, right? SIP TLS call trace.html. So if you just click on that, you will have your trace that shows up. So it's really good because you can just take it out of the system, download it, and then you can reopen it anywhere. And you see here, I have a call. You see the NAT that was used, it's called SIP TLS LAN 0. And actually here, the incoming and outgoing call is going through the same interface. And you can see the invite coming in. And the reason I know it's SIP TLS is because it's here. It says SIP TLS here. Otherwise, if you look at the rest of the message, the SDP that is being used, the calling number, call number, other calls that are being sent, you can't see that this is SIP TLS unless you look here. Okay, so the messages are all decoded. If I look at a TB trace, so TB trace, I showed you earlier that you just have to connect here and type TB trace, right, to start the to start a signaling trace, and you will capture it. So then if you open this signaling trace, I don't know why it's so small. You get the invite, and if you look at, well, here you see it's UDP. Okay, so the invite here is shown over UDP. So it's really the decoded portion of SIP. So Wireshark here doesn't require to have the private keys to see what is in this signaling trace, even if it's using an encrypted format. Okay, so the SBC uses the key and the certificate to decode the data. And then you have the TB router trace. Okay, so TB router trace is different. You need to use the tool we used yesterday. It's called TBX CLI Tools Remote. Again, you just need to type TBX and tab to get into there. So if I start this, let me just put it a bit bigger. Okay, like this, right? So you get into this menu here, and you have one application that's called TB Router here. Like I said, this is the SBC main application or core application where all the packets go through in and out of the system, all the packets that are LAN WAN interfaces. So the management traffic is not going through TB Router. So we just have to be careful here. It gets all the traffic that is called LAN WAN type. And if you click on TB Router, you get onto this page and you can see each of the IP interfaces that are managed by this TB Router application. Okay. You see other information like the IP addresses of these networks, which VLAN they're using, or if they are untagged like this one. You can also see how many packets are received, sent, packets per second, megabit per second on each of these network devices and each of these interfaces. And I told you yesterday also that if you look in the Linux kernel, you will see that TB router is running at 100% of CPU time, but the real CPU usage used by TB router is shown here. So you see it's being used at 3% right now. To be able to capture now our signaling trace, we can do P here. Okay, let me just show you. Okay, so you can do always question mark for help. So if I do question mark, you have a list of functions you can do here for controlling TB router. And the one we want to use now is this one, P, start, stop, packet capture. Okay, so I can do just type P. When I type P, I get into a menu like this, which allows me to capture some packets. The default capture buffer size is 64 megabytes. You can have only incoming traffic or only outgoing traffic. And you can specify just one VLAN ID here or -1 for having all VLAN IDs. Okay, so that's the general configuration. So you just need to press enter. And you see here the message on the bottom, start packet capture in and out 64 megabyte, all VLANs. Okay, and then when you are finished, you can just do P again, and this will stop all packet capture. The file will be displayed here. So this will tell you where the file that was captured is located. Okay, so you can just here copy this path. And then if I press escape twice to disconnect, and then here I can type Q to quit. And I use the path that I just captured from the TB router. I can see here that I have a new file that was captured by TB router. Now, here, if it's a regular SIP call, UDP or TCP, I will see it here. If it's a PCAP, a TLS SIP call, I will not be able to see it unless I have my private keys available. So I don't know, I have it here, an example, but I don't know if I have the keys configured. I will see it soon. Yes, okay. So if I take only here, when you get a TB router, you see TB router capture, you will get all the traffic. So you will get TCP, TLS, you will get also the ping. If you do some pings, you will see the ARP requests. So you will see everything that is going on through those LAN 1 interfaces. You also see here the RTP traffic. That's the only place where you can capture the RTP traffic is using TB router capture. Okay. So here, if I just do SIP to make sure I see only the SIP traffic, I can see here the messages. But these are just UDP traffic. This is not a TLS. Yeah, I can see some TLS messages are being sent here over, but unfortunately the SIP. Yeah, the SIP is not TLS here. You would have seen here using TLS. Okay, so anyway, but you see the other messages being sent, TLS requests being sent. Okay. Yeah, that's right. Yeah, they're not decrypted. I should see them here, but they're not decrypted. So I need to fix the keys there. TB router. Okay, so I'll try to fix that for tomorrow. Okay, so you have these examples of traces in the system. I mean, where you have the training material. Okay, so you have call trace example, signaling trace with TB sig trace and a TB router trace. Okay. Now, SRTP. Okay, so it's secure real-time transport protocol. It requires ProSBC version 3140 or more to support this. Now the difference here with SRTP and SIP TLS is that for each call, there are new keys that are generated. All right, so every time there's a new call that you require SRTP, the keys will be generated. They will be exchanged in the SIP messages from end to end. And obviously, the SIP messages should be encrypted so that the TLS encryption information is also encrypted. Both directions must use the same Cipher method, but a different encryption key. All right. The encryption key are automatically managed by the SIP stacks on both ends. All right. Once the SRTP session has been accepted, and if the SBC needs to convert RTP to SRTP, the encryption and decryption of the RTP and SRTP packets will be done by the TB router application. So you saw right now, we went to the TB router application and we have seen what it does, right? And one of the function it does, it transfers RTP to SRTP. Right now we use just one Cipher method and for outgoing calls, but on incoming calls we can accept multiple variants here. There's only one configuration to do for SRTP is you go in the profiles and you select the RTP security mode and you put secure. Okay, so the default is to have it non-secure or regular RTP. And then if you want to have SRTP, you can change it here to secure. But that's the only setting you need to do in the configuration. If you set here secure and you're not using a SIP TLS, you will get an error like this saying that you're trying to use secure RTP, but your signaling protocol is using UDP. So it's okay to do SRTP, but then it's easy to decode if your SIP is not encrypted. Okay. So you'll get a warning in that case. In the call trace, if you're using SRTP, you will see it in the call trace. Normally, it's RTP/AVP that is being displayed here. If you have a S here, that means your transmission of data will be encrypted. And you will get new entries like this in the SDP for selecting which crypto method will be used for your SRTP traffic. Okay. So this one is for the invite, and this one is for the 200 OK. So that's the remote side. Okay, so for SRTP troubleshooting, well, the only way to see the SRTP traffic is a TB router capture. To be able to decode the SRTP, you also need to have the SIP messages, because the SIP messages have the information that encrypts the SRTP. So if you have a TB router capture and you capture the SIP messages and the SRTP, and you have your private keys available, you can view everything in Wireshark. So Wireshark is intelligent enough to be able to first decrypt the SIP TLS with the private keys you have put. Second, to understand that the SRTP will be encrypted and decrypt that as well. Right? So it's very interesting to have this in Wireshark, but you need to have those private keys, otherwise you won't be able to see anything. And if you look in Wireshark trace, you will see the same type of information as we see in the call trace. For example, SAVP here, you will see the crypto entries in the SDP. So you can know that this particular SRTP stream will be encrypted. Yes, if you look at the, so these were the SIP messages. If you look at the SRTP or the RTP message itself, okay, you will see it still says here real-time transport protocol and not secure, but you can see down here that it uses SRTP, right? Encrypted payload, right? And if it's not decoded, you will see it like this. Okay, if it's decoded, then you will see it normally. Yeah. For debugging SRTP, we don't have a lot of things because it is very low level in the system. So like we said, we can use a TB router trace, but we can also check some information about the TB router at trace level 1 to be able to see what it does with the SRTP packets. And there's some information maybe in the Toolpack Engine application about SRTP, because that is the one that allocates the resource for doing the RTP to SRTP conversion. So you may be able to see some information in there. But like most of the things, if you can't use the regular tools to debug, like the signaling trace and the web portal and stuff like that, we will ask you maybe to give us those logs, and then we can help you to figure out why it's not working in your case. Okay? But as you see, it's not difficult to configure SRTP. You just have one setting to do. And if your SIP TLS is working fine, normally SRTP will also be encrypted and decrypted normally. Okay.